So hi everyone, myself Pankaj and welcome to the next video of solving most important DSA interview questions. So in today's video, we are again going to solve another graph problem and the name of the problem is network delay time. So in this problem, you are given a network of n nodes labeled from 1 to n. You are also given times, a list of travel times as directed edges. So basically times of I is equal to u of I, comma v of I, comma w of I, where u of I is the source node, v of I is the target node, and wi is the time it takes for a signal to travel from source to target. So basically what it's saying that you can see the input here. They have given a times vector. It's basically a vector of vector, right? And inside this, you are again given with a vector, and in each vector, you are provided with a source node. This is destination node, and this is the time in seconds that it will take for a signal to travel from source node to destination, right? And you are also given with value k. So k is basically the source node, right? Initial node from where the signal is getting started. And here n is equal to 4. So basically n is representing the number of nodes. And the numbering of nodes is basically from 1 to n, right? Here you can see in the example. Now what we have to do is we will send a signal from a given node k. So that's why I said k is as a source node, right? You will start from node k, return the minimum time it takes for all the n nodes to receive the signal. So if it is impossible for the node all the n nodes to receive the signal, so basically return -1 in that case, right? So what the question is saying that basically this is the graph that you will be given with, right? And there is a node k. So k is basically the initial node from where your signal is starting, and this signal will go to all the nodes available in the graph. So basically the signal here you can see you will go to node 1, again it will go to node 3, and from node 3 it will go to node 4, right? But what if the direction of edge was from 3 to 2, not from 2 to 3? In that case the signal will not go from 2 to 3. So in that case you will not be able to reach node 3 and 4. So in that case we will have to return -1. But in this case we are actually able to move from 2 to 3, then 3 to 4, right? So in this way you have to see that whether we are able to reach all the nodes or not from the given starting node, right? So here you can see that let's understand this problem using diagram here. So you can see here, so this was our source node, right? 2 was source node. So going to 1, so why we are able to go to 1? Because there is a directed edge from 2 to 1. So we can move from 2 to 1, right? And it takes 1 second for going 2 to 1, right? It also takes 1 second to going to 3, and from 3 to 4 it takes 1 second, right? But from 2 to 4 you can calculate the total time that it takes is that is 2. So what are the time that we taken from reaching all the nodes? For going to 1 we took 1 second, from 2 to 3 we took again 1 second, then again from 2 to 4 we took 1 plus 1 second, that is 2 seconds, right? From 2 we first went to 3, then again we went to 4. So it's taking basically 2 seconds, right? 1 second here and 1 second here. So what is the minimum time you are thinking that this signal is taking for reaching to all nodes? Please mark here, I am talking about reaching to all nodes, not to a single node. So you can see that the minimum time that it takes to reach all the nodes is basically 2. How? First it came to here at 1 second, then from here it went to 4 in 1 second. So the total time taken is basically 2 seconds, right? Right. So we have to find what is the minimum time that the signal will require to go to all the nodes. So for moving to all nodes here, we are taking 2 seconds, right? So basically you can notice here that we first going to each node in minimum time, right? So for going to node 1 we took minimum time as 1, for going to node 3 we took minimum time as 1, and for going to 4 from 2 we took minimum time as 2. But our answer is basically 2, right? So you can notice here is that we are actually taking the maximum of all the minimum time, right? So you must be thinking that you have seen this question or problem somewhere, right? So this is basically Dijkstra's algorithm, right? You have to find the minimum time from the source node to reaching all the other nodes, right? Dijkstra algorithm is the same, right? We find what is the minimum time that it will require from moving from source node to the all other nodes, right? So the same is Dijkstra algorithm. So this question is basically based on Dijkstra algorithm, and we have to basically apply Dijkstra algorithm to solve this problem. So what we will do, we will first apply Dijkstra algorithm. Dijkstra algorithm, right? And in the second place, what we will do, in this Dijkstra algorithm, what we were doing, we were basically maintaining an array, and initially all the distance of other node from the source node are basically marked as what? Infinity, right? Initially we marked it as infinity, and when we traverse this graph, and in minimum time we go to each node, and when we reach each node in minimum time, we basically update that distance in that distance array, right? So like this, right? Let's say take 2 seconds, right? So we will find this array, and after finding this array, you notice that we actually took the in this case 2 as our answer, right? The distance array will be 1, 1 and 2, right? In this case, but the answer was 2. Why? Because we have to reach to all the nodes, so minimum time it will take is 2. So we will find this array, distance array, and take the maximum of all these elements, right? So maximum will be the answer of this question. So here comes the concept that how you will what is Dijkstra algorithm and how we will solve this question, right? So let's understand our Dijkstra algorithm here, right? So now our question is basically how you will use Dijkstra algorithm. So how Dijkstra algorithm works is that, let's say you are given a source node here. So basically 0 is the source node, right? And you have to go to all the other nodes, So basically you have to find the minimum distance from this source node to all this other node, right? So how you will find that? So in this case, in this Dijkstra algorithm, what we do is, first of all, what we will do, we will basically make a distance array. So this is what we called as distance array, right? Let's call it a distance array, and the size of this distance array will basically be equal to the number of nodes, right? So there are 4 nodes here, so let's take 4 elements here. And initially what we will do, we will basically initialize all the elements inside array with infinity. So for infinity, let's take this as sign, right? So let's take this as infinity, right? So we will initialize all the elements with infinity, right? So this is our distance array, right? Now we will start moving to each node in a shortest path, right? So here you can see that, first of all, what I have did is I have created adjacency list. So if you don't know what is adjacency list, so please watch my previous videos. So basically adjacency list is the so it's the list of neighbor elements of a node, right? So you can notice here, for node 0, what are the adjacent nodes? 1 and 2 is the adjacent node. So here I have used pair, right? So this is one node, so this is node 2, right? And in the second part of this pair, what I have stored, it's basically the weight. So weight is basically the time it takes from going 0 to 1, right? So you can see here 5 is the weight. So I have stored that 5 here, right? Again, for node 1, 0, 2 and 3 are the neighbors. 0, 2 and 3 are the neighbors for node 1. So here I have stored it, right? Again for node 2 and node 3. So this is basically the adjacency list. So you will see in the code that how I have created it, right? So now I have created an adjacency list and distance array. So what we will do, we will start moving from node 0 to its neighbors. So let's say, so we will move to its neighbor, which are the shortest one. So here you can see that going to 1 takes lesser time than going to 2 from 0, right? So what we will do, we will first go to 1. So let's see, we came to 1, and what is the time taken? So basically, so this is okay. Let me first index it out. So I have indexed it out, right? So I have indexed it, right? Now for node 0, going to node 0 from 0 is basically it will take the what? Let's write it here. So basically going from node 0 to 0, it will take what? 0 second, right? Now when you go to node 1, so basically we were able to go to node 2 also, but node 2 taking 8 seconds. So we will go to minimum. So we will go to that node which takes minimum time from source, right? So 1 is taking 5, so it's minimum, then 8, right? So we will go to 1. So here let's again mark it as 0. So we gone to 1, right? Now what we saw that reaching 1 from node 0 taking 5 seconds, right? So here initially what we had done, we had stored infinity. So 5 is basically lesser than infinity. So we will update this distance array for node 1, right? So it's basically representing that from going from node 0 to 1, it's basically taking 5 as minimum time as of now, right? In future we can also update it to a more minimum value, right? Now you came to 1. Now you want to go to all the neighbors of node 1, right? Again, when you came to 1, you will go to all the you are able to move to all the neighbors of 1. So you can either go to 0, either go to 3, or either go to 2, right? So what is the minimum time that it takes while going to other nodes? So you can see here it takes 9 here, 5 here, and 2 here. So what is the minimum? So 2 is the minimum. So we will go to node 3 from node 1, right? And what is the time it's taking from node 0? We have to calculate the time from node 0. So what we will do, you will basically plus this 5 and 2. That will be the distance of node 3 from node 0. So 5 plus 2 is basically 7, and 7 is basically the lesser than infinity. So we will update it out, right? Now you came to 3, and what are the neighbors of 3? So 1 and 2 are the neighbors of 3. So where you will go? Now from node 3 you can go either go to node 2, and again either you can go to node 1. But if you will add the distance again, so what it will take? 5 plus 2 again. So what it's coming? It's coming 9. And when you go to 2, so basically for when you go to 3 to, from 3 to 1, it's basically in this case taking 9. But here you can see that coming to node 1 is basically taking 5. So 5 is the minimum, then 9. So we will not update it. Now let's consider the other case when you will go to node 2. So how much time it will take? 5 plus 2 plus 6. So what it's totaling? So it's basically 5 plus 2 is 7. 7 plus 6 is 13. But going to 2 is basically taking 7. So 7 is the minimum. So 7 is the lesser than 9. So we will not update it, right? How you are coming to 2 taking 7 as time as your what? So here we have done a mistake that we have actually updated here the going to node 2 is taking 7. So basically going to node 3 is taking 7, right? Now the other case is that you can either, we have seen that you can go to from 3 to 1, right? Now you can also go to from 3 to 2, right? So it's taking basically 5 plus 2 7 plus 6 13. So going to 2 is basically taking 13. So in 13 is basically lesser than infinity. So let's update it, right? Now you came to node 2, right? From node 2, where you can go? From node 2, I can go to either 1, either 0, or either 3. So let's say going to 3 is basically taking 5 plus 2 plus 6, what? 7 plus 6, 13. And 13 plus 9, again, what? So 9 plus 13 is basically 22. So going to 1 is taking 22 in this case, but we have already gone to 1 using 5 seconds, right? So 5 is lesser, so we will not update it. Now you can also go to from 2 to 8. So what you will do, we came here from here, right? The time that we had taken from coming to 3 was 7, then 13, then again we add 8. So it's basically 13 plus 8 is 21, right? So we will not update this 0. Why? 0 is lesser than 21, right? Now again you can go to back to 3, right? So it will again take longer time, so we will not go. Now there is a last call for this node 0. Why? From node 0 we had went to node 1, right? Now the last call will be there for this node 0, that you can also go to node 2, right? So going to node 2 is taking basically 8 seconds, and in our previous case so it was basically 13 here, right? Right. Now you can come to node 2 by just taking 8 seconds. So here we had in previous case updated it as 13. So 8 is basically lesser than 13. So we will basically update it out, right? So 8 is the minimum. So you can see that we have got our distance vector as 0 5 8 7. You can see here this is the answer 0 5 8 7. So this is the minimum time that you will take from source node, that is 0, to visit all the other nodes, right? So you can try run and check this out. So this will be the minimum, this will be the answer, right? So if it was the question of our previous, so if it was the input of our previous question, so what will the answer? So our answer will be 8, right? So we have to take the maximum time that it takes reaching all the nodes. Now for tracking, how you are tracking that whether we have already visited this node and have distance already calculated. So we will use a set for that, right? If in our set, let's say we will use a set, right? If in our set initially what we will do, we will basically push the and we will basically use a pair of set, right? And in that pair, the first element will represent the distance and other element will basically represent the node. So initially what we will do, we will basically push the pair of source node, that is first the distance is basically 0 from source to source, and this will be the node, that is 0 in this case, right? And we will check whether we have already calculated minimum distance for any node, and we will check that distance. If that distance is smaller, so we will update it out, otherwise we will not update it, right? So let's see how we will code it out. So basically we have to code the Dijkstra algorithm here, right? And in this case, in this question, we have provided with a directed graph. So the example that I have shown you, it's basically undirected graph. So 1 is the neighbor of 0 and 0 is the neighbor of 1, right? So but in our question, they have provided a directed graph. So basically here in this case, you can see here that, okay, where is the eraser? You can see here that 1 is the neighbor of 2, right? But 2 is not the neighbor of 1, right? So we have to keep this in mind, right? So now, first of all, what we will do, you will basically calculate, create the adjacency list. So for that, what we have to do, we have to create an unordered map, right? Unordered map of type int, comma, you have to create, let's create it as a list of pair, right? Why we are using pair? Because we have to store source node against our source node. We have to store what? Destination and the time that it's taking. That's why we are using pair, right? So let's say it is int comma int adj, right? Now what we will do, you will basically traverse your times vector, right? From I is equal to 0, I is less than times dot size, right? I plus plus. First of all, what you will find the source node. So basically we are traversing this array, and the first element of this array is basically the source node. Source, it's not source actually, it's basically representing that from node 2 there is an edge to node 1, right? In this case, from node 2 there is an edge to node 3, and the third term is basically the time it takes from going to that node other node, right? So this is this from node 3 going to node 4, it's basically taking one time. So there is an edge between node 3 to 4. So we will have to, let's find that first element. How you will do, let's call it as u, right? Now it's basically times of I comma 0, right? So it's u. What will be your v? Times of I comma 1. And what will be your weight? So weight will be times of I comma 2, right? Now you found out the so we have to create edge. So how you will do, you will basically create adj of u dot push back. What you will push, you will basically push the pair. So pair of what? It's basically the where its node is going to, that is v, and what its time taking, that is w, right? So we have created this adjacency list, right? So after creating this adjacency list, we will be creating what? We will be creating our distance vector, right? So our distance vector will be vector of type int. Let's name it as distance, and its length will be basically n plus 1. I'm telling you why. So let's initialize it with int max. So it's basically initializing with infinity, right? So why we have taken the size of this vector as n plus 1? So you can see here in the question they have given that the numbering of our nodes are basically from 1 to n. So right, and we know that the indexing of vector is done from 0, right? So let's say this is our distance vector that we have created, right? So it will have some partitions, right? So let's say there were 1 2 3 4 5 nodes, right? 5 nodes. So when we will be using our distance vector, so the index will be used as nodes, right? So here it will the zeroth index, then 1, then 2, this is 3, 4, and the last one is 5. So when we will be using our index as nodes, so we have to consider this, right? We don't have to consider node 0 because there will be no node 0 in our question. So we have to ignore this out. That's why if our n is given, number of nodes are given 5, so we have to consider this out. And this will come in your vector internally. That's why we will create one bigger size vector. So we have, let's say n was 5, so we are creating vector of size 6 in order to handle this 0 index value, right? So we will not include it in our node. So that's why we are using a one size bigger vector, right? And we have initialized this vector with maximum value, that is infinity. Now what I had said you that we will be using a set for tracking whether we have marked the minimum distance for a particular node. So this set will be basically of type pair int comma int. Let's call it as st, right? And initially what we will do, we will mark our distance array of source. So source is basically k here, right? So signal is starting from k, so its distance will be 0 because going from source to source is basically 0, right? It will take 0 time. And inside our set, what we will do, we will basically insert the first pair. So first pair will be first node, that is what was our first node? The first node our was 0. No, this is not node. So inside our pair, we are basically, the first element will be the distance and the first node. The second element will be node. So this is the distance, and this is node. So what does it mean? That this is the source node, and going from source node to source node, it's basically taking 0 seconds, right? So we pushed it out and we mark the distance of that source node to 0 inside our distance vector. Now we will have to run our while loop until our set is empty, right? So we will run while loop until our st is not empty. Right. So what we'll do, we will first find the top element that is present. So let's call it as int top is equal to what? st dot begin. So it will basically, it represents basically what? It basically represent the iterator. So in order to find the element, we will have to use dereference operator. So it's basically star. You must have studied this in pointer. So we found that pair. So we found that pair, that 0, 1. So the first element will be, so what was the first element? Top. It was basically distance. So let's call it as top distance. What it will be? It will be basically top dot first. And what was the second element? So it was basically node. So let's call it as top node, top dot second. So we found both the elements of that pair inside set. So now what we will do, we will first erase that pair from our set. st dot erase what? So what we have to erase? So basically first we will erase st dot begin. The first pair of the set, we will erase it out. Now since we have found the first pair of the set, so here you can understand using the example. So we found first pair, right? And let's say here we found a 0, 0, right? 0, 0. Now what we were doing, we were going to its neighbor, checking for its neighbor which is minimum, right? So that's why for checking minimum distance, which is minimum distance 8 and 5, we are using set. You must be knowing that set store elements in sorted order. So we will basically go to its minimum elements first checking. So we will first traverse its neighbors. So let's call it as neighbor of what? You can find it at adjacency, and you will find the neighbor of top node. You will go to that node's neighbor and you will check if Okay, let's call it as node distance, right? If your node distance plus what, let's copy this out. If your node distance plus a neighbor dot second. So what's neighbor dot second is representing? So neighbor is basically, we are considering this adjacency list, and inside this let's say zero's neighbor was 1, right? So we are here, and the neighbor dot second is basically 5. So we are calculating that if 0, that 0 basically this is 0, 0 plus this 5, if 0, if this plus this is basically less than this minimum distance that we have stored in our distance vector, then what we will do, we will basically update it here, right? So we are doing the same here. If it is what, less than a distance of neighbor dot what, first, so in that case what we will do, we will basically update our distance vector, right? So first of all, what we have to do, we have to find its record in our set. So let's call it as auto record is equal to st dot find. What we are going to find, just the pair. So what is the pair? So is pair is basically a distance of what, neighbor dot first and neighbor dot first. So you must be getting confused here. So what's this meaning, I'm going to tell you. So inside, so this is neighbor dot first. So what was neighbor dot first in that case? So neighbor dot first was what, this is distance, right? No, neighbor dot first was basically the node that we have stored in our adjacency list, right? So neighbor dot first is node, and corresponding to this node, what is the distance, right? So we are actually, this whole part is representing the distance, and neighbor dot first is basically the node, right? And you should remember that in our set we had stored the first element was distance and the other element was node. So we are checking that whether we have already some entry in our set corresponding to that distance and node, right? So if that is present, so what we will do, if your record is not equal to st.ind, so it means that if that record is present, so what you will do, you will basically erase that out. Why we are erasing it? Why? Because we have got some minimum distance here, right? That's why we are erasing it out. st.begin, right? Sorry, we have to erase the record. Now you have erased it out. So now you have erased it out. So what we will do now, we will update that distance, minimum distance in our distance vector, right? So neighbor dot first. So neighbor dot first is basically what? It's node, right? So corresponding to that node in distance vector, we are storing the minimum distance. So what was the minimum distance? So this was the minimum distance, right? So let's update it. So we updated it here. Now we will insert its entry in our set. So what entry we will insert? So we got the minimum distance. So we will provide the minimum distance. So minimum distance is stored in distance vector. So distance, okay, distance vector of neighbor dot first, right? And the second element is neighbor dot first. So this is the pair that we have inserted in our set. Now when you will come out of this while loop, you will be having with you this distance vector, right? So this will be your distance vector. Now you got this distance vector, but our answer was the maximum value, right? So we will have to find that maximum value. Let's declare an variable as long answer is equal to -1, right? Now what we will do, you will basically traverse that distance vector from actually 1. So 0 is basically infinity, right? So we are not considering that 0 node, right? So we are traversing that distance vector from 1, and we will go up till what, distance dot size I plus plus. We will check if your distance of I is greater than answer. So you have to take that, store that answer inside your answer variable. You have to store that distance in your answer variable. So what will be the distance? So distance of I, right? Now at the end, what you will do, you will basically check if your answer is equal to int max. In that case, it means that you cannot reach uh, all the nodes with that signal, right? So we will basically have to return -1 in that case. Else what we'll return, we will return the maximum value that is stored in our answer variable, right? So now let's try to run this code. Okay, we are doing some mistake. Not on map. Okay, we have to give one more arrow here. Okay, now let's run it again. Error, no variable conversion. Okay, we have to take it as auto, right? We are taking it as int. It's basically pair, right? So it will automatically take as pair when you will use auto. Now node distance. Node distance, what do you mean node this? Okay, let's call it as node distance. So our first state case is getting failed. Okay, why? Let's check me out. Okay, there is an error here. We are actually initially pushing 0, 1. So 1 is the basically source node that I had considered, but source node is basically k that we have provided in our question parameter that you can see here, right? Now let's try to run this out. So you can see here our public test cases are passing now. Let's try to submit this. So you can see our code has been accepted. And so talking about the time complexity of this code, so basically we are traversing our graph. So it's basically will be equal to what the time complexity of Dijkstra algorithm. So time complexity of this Dijkstra algorithm is basically big O of E into log of V, where E is the number of edges and V is the number of vertex, right? And space complexity is basically big O of N plus E, right? So I hope you have understood this question, and it is the level of this question is basically medium, right? So it's not an easy question. So if you don't got it, so let's again watch this video. So so that's all about in this video. So let's meet in the next video. Until then, have a nice day.